When we have solutions, we can have osmosis. Osmosis is the movement of a solvent through a selectively permeable membrane. A cell membrane is a selectively permeable membrane, and you have osmosis ongoing between your blood and your body cells. What happens in osmosis is water and small molecules, we're not going to worry about that, we're just going to worry about the water, to flow through the membrane, but all the things dissolved in it cannot. So let's look at what happens in osmosis. When you have a more concentrated solution on one side and a less concentrated solution on the other, water is going to go where there is more water to where there is less water. In other words, water moves from where there's a low concentration of solutes to where there's a high concentration of solute. I say that water tries to dilute the more concentrated solution. Osmosis really occurs because there's order when you have more concentration on one side. And so it's really trying to become more disorganized. But it can't do that by mixing because that membrane is stopping the solute from mixing around. So the water basically moves over and dilutes it down. What stops the water from coming over completely and diluting it down all the way is that pressure will build as water moves from one side to the other. There's going to be an increase in pressure because either it's going to be filling up a column as shown in this part right here. You can see as the water flows from here to here, more concentrated here, less concentrated here, water flows over, and as the water flows over, you start building up a column of solvent over here. That's going to be pressing down, and when it gets a high enough pressure pressing down, it stops the osmosis. That's why it's called osmotic pressure. If this was a sealed container like a cell, what would happen is the water would flow in until there was a certain amount of pressure that stopped it from occurring. When talking about osmosis, we use certain terms to describe the solutions with respect to typical blood and cell concentrations. So if I look at a solution that has a low concentration relative to blood or cell concentration, we call that hypotonic. In a hypotonic solution, water is going to flow from where it's a low concentration, hypotonic is low concentration, to where there's a greater concentration in the cells. The cells then swell and burst. If it's red blood cells that swell and burst, that's called hemolysis. Hypertonic means too high a concentration. So the concentration of what you have, the solution that you're dealing with, is higher than that what you would find in blood or around a cell. So what happens is water is going to flow from inside the cell out. So the cell will shrink and shrivel and actually come to a point where it's not viable anymore. If that happens to red blood cells, we call that crenation. Isotonic means same concentration. So if I have an isotonic solution, it has the same concentration of solutes as the inside of a cell, and there's no flow of water. Isotonic concentrations are 0.92% of sodium chloride and 5% of glucose. These concentrations I expect you to know for an exam so that you would be able to predict what would happen. Now, a cell does not contain 0.92% sodium chloride and 5% glucose. When we are looking at the isotonic concentrations, we're looking at what is the overall effect of all of the solutes on osmotic pressure. And so it's equivalent to 0.92% or 5% glucose. So now, knowing what you know about osmosis, look at each of these solutions and describe them as isotonic, hypotonic, or hypertonic. Well, isotonic is the 5%, of course. We just looked at that. Sometimes it's given as 4.5%, but we're rounding off. Hypo means too little. So hypotonic is going to be the 1% solution. Hyper means too much. So the hypertonic solution is 10% glucose. When a strawberry is placed in distilled water, which way will the water flow? Into the cells of the strawberry or out of the cells of the strawberry? Well, we already know that distilled water has no solutes in it. It's absolutely pure. So it must be hypotonic. So water is going to flow from the distilled water into the strawberry, and it'll get all big and swelled up and squishy. When a red blood cell is placed in a 2% sodium chloride solution, which way will water flow? Into the cells or out of the cells? 2% sodium chloride is hypertonic because isotonic is 0.92%. Well, if 2% is hypertonic, that means the red blood cells are going to allow the water will flow out of the red blood cells into the 2% sodium chloride solution, trying to dilute it down. Crenation will occur.